തുടർച്ചയായിട്ട് ഇന്ന് നമുക്ക് എഞ്ചിനീയറിംഗ് മാത്തമാറ്റിക്സിലെ ഒരു സെഷനാണുള്ളത്. ആദ്യമേ തന്നെ ഇന്നത്തെ സെഷനിലേക്ക് ലോഗിൻ ചെയ്തിട്ടുള്ള എല്ലാ S2, S4 വിദ്യാർത്ഥികളെയും അസാപ്പിന്റെ ഓൺലൈൻ സെഷൻസിലേക്ക് സ്വാഗതം ചെയ്യുന്നു. ഈ ലോക്ക്ഡൌൺ കാലഘട്ടത്തിൽ വീട്ടിലിരുന്ന് സമയം കളയാതെ അവരവരുടെ പാഠഭാഗങ്ങൾ പഠിക്കാനായിട്ട് കാണിക്കുന്ന നല്ല മനസ്സിനെ ആദ്യമേ തന്നെ അഭിനന്ദിക്കുന്നു. ഇന്ന് നമുക്ക് ലാപ്ലാസ് ട്രാൻസ്ഫോം എന്ന് പറയുന്ന ടോപ്പിക്കിൽ രണ്ടാമത്തെ സെഷനാണ്. ഇന്നലെയായിരുന്നു ആദ്യ സെഷൻ, അതിന്റെ തുടർച്ചയായിട്ട് ആണ് ഇന്നത്തെ സെഷൻ. നിലവിലെ S2 വിദ്യാർത്ഥികൾക്കും S4 ചില സെലക്ടഡ് ബ്രാഞ്ചിലെ വിദ്യാർത്ഥികൾക്കുമാണ് ഈ ഒരു ടോപ്പിക്ക് അവരുടെ സിലബസിലുള്ളത്. ഇന്ന് നമുക്ക് ലാപ്ലാസ് ട്രാൻസ്ഫോം എടുക്കുന്നത് നമ്മുടെ വെരി ബിലോവ്ഡ് സുമേഷ് സർ ഈസ് ഹിയർ. So Sumesh sir is an assistant professor from the Department of Science and Humanities, 𝐿SAT Angamali. He has a vast experience of 50+ years in this field. സാറിനെ വളരെ സ്നേഹത്തോടെ ആദരവോടെ അസാപ്പിന്റെ ഓൺലൈൻ സെഷനിലേക്ക് ഒരിക്കൽ കൂടെ സ്വാഗതം ചെയ്യുന്നു. ഒരിക്കൽ കൂടെ ജോയിൻ ചെയ്തിരിക്കുന്ന എല്ലാ വിദ്യാർത്ഥികളോടും നന്ദി അറിയിക്കുന്നു. താങ്ക്സ് ഫോർ ജോയിനിങ്. സ്റ്റേ ഓൺലൈൻ. It's over to you, sir. You may start now.
Thank you, Santosh Kumar, for your nice introduction, and good morning to all students. Today's session is the continuation of last session, and these are the contents of today's presentation, which first two sessions we already discussed in the last session. Laplace transform of elementary functions. It is the building block of Laplace transform, and students have to memorize these results. Till the end of this module, these 9 results are basic building blocks of Laplace transform, and we use this result in each and every problems. And we discussed shifting property also in the last session. The property was if Laplace transform of f of t equal to f of s, then Laplace transform of e raised to at into f of t can be obtained by replacing s by s minus a in the expression f of s, and Laplace transform of e raised to minus at into f of t, which can be obtained by replacing s by s plus a in the expression f of s. These two topics we discussed in the last class. And moving on to today's presentation, derivative of transform or multiplication by e raised to n property. The property is if L of f of t equal to capital F of s, then L of e raised to n into f of t equal to minus 1 all raised to n into d raised to n by ds raised to n of f of s. That is, if the function f of t is multiplied by power of t, then we have to use this concept. And in particular, Laplace transform of e into f of t is equal to minus 1 into d by ds of f of s, which is obtained by substituting n equal to 1 in the general result. Again, Laplace transform of e square f of t is equal to minus 1 whole square, it becomes plus 1 into d square by ds square of f of s. Normally, in the university questions, there are expressions, or we have to find Laplace transform of functions multiplied by e square, e cube, etc. So this is transform of derivative of transform or multiplication by e raised to n property. We move on to problem session. first problem. Find the Laplace transform of t cos at. So here cos at it is multiplied by t. So when the question is multiplied by t or power of t, we have to use the above concept. So in this case, first we have to find the Laplace transform of remaining expression, that is other than t or power of t. So here the remaining expression is cos at. So first we find Laplace transform of cos at. Then apply multiplication by t or t raised to n property. Here we have to apply multiplication by t property because the function is multiplied by t. And we have Laplace transform of cos at is given by s by s square plus a square. We denote this expression as f of s. Then we use multiplication by t property. So we obtain Laplace transform of t into cos at equal to minus 1 into d by ds of f of s. For this problem, f of s equal to s by s square plus a square. So this becomes minus 1 into d by ds of s by s square plus a square. Now we have to differentiate the expression s by s square plus a square. For that, we have to use the quotient rule. So this is equal to minus 1 into denominator into derivative of numerator. Here numerator is s, its derivative is 1 with respect to s, minus numerator s into derivative of denominator. Here denominator is s square plus a square, its derivative is 2s, all divided by denominator square. By reducing, we obtain the final answer as s square minus a square all divided by a square plus a square the whole square. And second question. Find the Laplace transform of t square sine 2t. In this case also, the question is multiplied by power of t. Here power of t is t square. So consider the remaining expression. Here the remaining expression is sine 2t. So first we find the transform of sine 2t. Is of the form sine at. Sine at is having Laplace transform a by s square plus a square. And here a equal to 2. So we have Laplace transform of sine 2t equal to 2 by s square plus 2 square. Is denoted by capital F of s. Then we use multiplication by e raised to n property. And in this case, n equal to 2 because the expression is multiplied by t square. So it becomes minus 1 all square into d square by ds square of f of s. And here f of s equal to 2 by s square plus 2 square. So we have to differentiate 2 by s square plus 4 twice with respect to the variable s. So this can be written as d by ds of 2 by s square plus 4. Now d by ds of 2 by s square plus 4. This is of the form derivative of 1 by x. And we have derivative of 1 by x is minus 1 by x square. Applying this result, we get derivative of the expression in double bracket equal to 2 into minus 1 divided by s square plus 4 whole square into derivative of s square plus 4 is 2s. So it reduces to d by ds of minus 4s all divided by s square plus 4 the whole square. Again, we have to apply differentiation. For that, we have to use quotient rule. A square plus 4 whole square is the denominator into derivative of minus 4 is minus 4 minus numerator into numerator is minus 4s into derivative of denominator. Here the denominator was a square plus 4 the whole square. Its derivative is 2 into a square plus 4 into 2s all divided by denominator square. So denominator becomes a square plus 4 the whole raised to 4. Here we can take a square plus 4 outside. By reducing, we obtain the final answer as 12 a square minus 16 all divided by a square plus 4 the whole cube. Then we move on to next question. Find the Laplace transform of t into e raised to minus t into sine 3t. This question contains t as well as e raised to minus t. So here we have to apply two properties. Since it is multiplied by exponential term, we have to apply first shifting property. Again, it is multiplied by t. So we have to apply multiplication by t raised to n property also. So we have to use two properties we already discussed in this question. So in this pattern of questions, that is multiplication by t and exponential term, we apply shifting property last. So first we find Laplace transform of sine 3t, then find Laplace transform of t sine 3t is using multiplication by t property, and finally apply the shifting property to obtain Laplace transform of e raised to minus t into t sine 3t. So this is the order we have to follow. Now, Laplace transform of sine 3t is of the form L of sine 80. L of sine 80 is a by a square plus a square. Here a equal to 3. So it becomes Laplace transform of sine 3t equal to 3 by a square plus 3 square. We denote it as f of s. Then by applying multiplication by t property, we obtain Laplace transform of t sine 3t is equal to minus 1 into d by ds of f of s, because this is multiplied by t. This is equal to minus 1 into d by ds of, here f of s is 3 by a square plus 9 is equal to minus 1 into. Again here we differentiate the expression using the result d by dx of 1 by x is minus 1 by x square. So using the result, we get the expression as 3 into minus 1 by a square plus 9 the whole square into 2s. Reducing the expression, we get 6s divided by a square plus 9 whole square. We denote the expression as g of s. Is the Laplace transform of t sine 3t. But the question was Laplace transform of t e raised to minus t sine 3t. So again, we had to apply one more result. We had to use the first shifting property to complete this problem. So by applying first shifting property, we obtain Laplace transform of e raised to minus t into t sine 3t is equal to g of s plus 1, because the expression is multiplied by e raised to minus t. Then its Laplace transform can be obtained by replacing s by s plus a in the Laplace transform of remaining expression. Here remaining expression is t sine 3t. Its Laplace transform is is denoted by g of s. Therefore, Laplace transform of e raised to minus t into t sine 3t equal to g of s plus 1. By replacing s by s plus 1 in g of s, we get 6 into s plus 1 all divided by s plus 1 whole square plus 9 the whole square. Here we can expand the denominator using a plus b whole square. So it reduces to 6 into s plus 1 all divided by s square plus 2s plus 10 the whole square. One more question. Find Laplace transform of e raised to minus 3t into t cube. Here, the expression contains, or expression is product of two terms, e raised to minus 3 and t cube. This property can be done in two different ways. Either we can apply first shifting property or multiplication by t raised to n property. Here, we first find Laplace transform of t cube. Laplace transform of t cube is of the form Laplace transform of t raised to n. Laplace transform of t raised to n is n factorial by s raised to n plus 1. So Laplace transform of t cube equal to 3 factorial divided by s raised to 3 plus 1. Reduces to 6 divided by s raised to 4. We denote it as capital F of s. And apply first shifting property. Laplace transform of e raised to minus 3t into t cube, which is equal to capital F of s plus 3, because here a equal to 3. And f of s was 6 divided by s raised to 4. So we obtain the final answer as 6 divided by s plus 3 the whole raised to 4. This is one method to complete this problem. Second method is, it is very lengthy because if we use multiplication by t raised to n property, here t raised to n, here n equal to 3. So we have to differentiate 3 times the Laplace transform of e raised to minus 3t. It is a lengthy procedure. So when a question contains exponential term and multiplication by a power of t, we have to apply shifting property last. That is the order we have to follow. In every question, we have to apply shifting property at the end of the corresponding procedure. Next is another property, integration of transform or division by t property. Integration of transform or division by t property.
Yes, sir. Can you hear? Sorry to interrupt.
Okay.
Sir, നമുക്ക് ഒന്ന് രണ്ട് അടുത്ത പ്രോപ്പർട്ടിയിലേക്ക് പോകുന്നതിന് മുമ്പ് ഒന്ന് രണ്ട് സംശയങ്ങൾ വന്നിട്ടൊന്ന് ക്ലിയർ ചെയ്ത് പോകാമോ?
Okay. Carry on.
ഓക്കെ സർ, ഒരു ക്വസ്റ്റ്യൻ ചോദിച്ചിട്ടുണ്ട്. അജിത്ത് മാങ്കോട്ടിൽ ചോദിച്ചിരിക്കുന്ന ക്വസ്റ്റ്യൻ ആണ്. When in multiplication by t raised to n, what should we do if n is lesser than 0?
Here n should be greater. In these type of problems, n should be a positive integer. N must varies from n equal to 1, 2, 3, etc. N should be a positive integer.
I think it's clear for those who asked the question. Now, sir, മറ്റൊരു കാര്യം ചോദിച്ചിരിക്കുന്നത് question 1, സാർ ഇപ്പോൾ നേരത്തെ ഡിസ്കസ് ചെയ്ത question 1 സംബന്ധിച്ചാണ്. Can question 1 can be solved using first shifting property and using complex identity? ഒരു ചോദ്യം ചോദിച്ചിട്ടുണ്ട് അഭിജിത്ത് രാജ്.
For the first question.
For the first question, can this be solved using first shifting property and using complex identity? ഒരു ചോദ്യം ചോദിച്ചു.
It is a lengthy procedure. Cos AT can be written as, in terms of exponential function, this can be written as e raised to iat plus e raised to minus iat whole divided by 2. And it is again very lengthy procedure. So this is the simplest way to find the Laplace transform of e cos it.
ഓക്കെ സർ, ഈ ക്വസ്റ്റ്യനിൽ തന്നെ ഒരു സംശയമാണ് ചോദിച്ചിരിക്കുന്നത്. ഈ ഫസ്റ്റ് ക്വസ്റ്റ്യന്റെ ആൻസറിൽ നമ്മുടെ ഡിനോമിനേറ്റർ എക്സ്പാൻഡ് ചെയ്ത് എഴുതേണ്ട കാര്യമുണ്ടോ ഇത്തരം ആൻസേഴ്സ് എഴുതുമ്പോൾ?
അത് അത്ര ഡീറ്റെയിൽഡ് ആയിട്ട് എക്സ്പാൻഡ് ചെയ്ത് എഴുതേണ്ട ആവശ്യമില്ല. റെഡ്യൂസ്ഡ് ഫോർമാറ്റിൽ എഴുതിയാൽ മതിയാവും. എക്സ്പാൻഡ് ചെയ്താൽ കുറച്ചുകൂടി ലെങ്തി ആവും. അപ്പൊ ഈ ഒരു ഫോർമാറ്റ് ഫോളോ ചെയ്യുന്നതായിരിക്കും നല്ലത്. ഇനി ക്വസ്റ്റ്യൻസ് ഉണ്ടോ?
സർ, അത്രയാണ് നമുക്കിപ്പോൾ ഉള്ള ഒരു കുറച്ച് വാലിഡ് ക്വസ്റ്റ്യൻസ് ആയിട്ട് വന്നിരിക്കുന്നത്. ബാക്കി ക്വസ്റ്റ്യൻസ് വരുന്ന പക്ഷം സാറിന് ഞാൻ
Okay, now I move on to next session. Integration of transform or division by t property. The property is, if Laplace transform of f of t equal to capital F of s, then L of f of t by t is equal to integral s to infinity f of s ds. So here the function f of t is divided by the variable t. In such cases, first we find the transform of the numerator expression. Here numerator expression is f of t. So first find the transform of f of t. This is the numerator function and denote it as f of s. Then integration of transform property says that, or division by t property says that, Laplace transform of f of t by t is obtained by integrating the expression f of s between the limits s and infinity with respect to the variable s. So this is division by t property. Now I move on to problems. First one, find Laplace transform of 1 minus e raised to t whole divided by t. So first look into the question. Here the expression is divided by the variable t. So in such cases, we had to use division by t property. So first to find the Laplace transform of the numerator function. Here the numerator function is 1 minus e raised to t. So first to find the Laplace transform of the numerator expression. So we have Laplace transform of 1 minus e raised to t. Here we apply the linearity property. So it becomes Laplace transform of 1 minus Laplace transform of e raised to t. Now Laplace transform of 1 is 1 by s. Laplace transform of e raised to t is of the form Laplace transform of e raised to at. And here a equal to 1. A is the power of, coefficient of t, the exponential type. And in this case it is 1. So Laplace transform of e raised to t is 1 by s minus 1. We denote this expression as capital F of s. Then we apply division by t property. By division by t property, we have Laplace transform of 1 minus e raised to t divided by t equal to integral s to infinity f of s ds. Here f of s is 1 by s minus 1 by s minus 1. So substituting, we get integral s to infinity 1 by s minus 1 by s minus 1 into ds. We can integrate this expression. Integral 1 by s, it is of the form integral 1 by x dx. Integral 1 by x dx is log x. So integral 1 by s is log s minus integral 1 by s minus 1. Integral 1 by x minus a format. Integral 1 by x minus a is logarithm of x minus a. So integral of 1 by s minus 1 is log s minus 1 between the limits s and infinity. And first we have, in these type of problems, we have to apply the rules of logarithm. This is of the form log a minus log b can be written as log a by b. So this becomes logarithm of s by s minus 1. This we have to note very carefully because we have to apply the limit infinity. This is not finite limit. So we have to do, or we have to follow this pattern. Not directly substituting the limit in this expression. First we have to apply rules of logarithm. So it becomes a logarithm of s by s minus 1 between s and infinity. Again, we cannot directly substitute the limit here because the upper limit is infinity. If we put infinity here, infinity divided by infinity minus 1. Infinity minus 1 is again infinity. Infinity by infinity is indeterminate form. So to find the upper limit, we have to make another rearrangement. Here we have to take, or we have to cancel the positive powers of s from the corresponding ratio. So we take s outside from the denominator. So now we can cancel s. So it reduces to logarithm of 1 divided by 1 minus 1 by s between s and infinity. Now we can substitute limit here. Upper limit is infinity. So s is replaced by infinity. We obtain the expression in the first square bracket minus lower limit is s. So we obtain the same expression is found in the second square bracket. Now 1 by infinity equal to 0. So first term becomes logarithm of 1 divided by 1 minus 0 minus second term is same thing. First expression reduces to log 1 minus second term. Here we can take LCM. LCM is s. So denominator becomes s minus 1 whole divided by s. S becomes in the numerator. So it reduces to logarithm of s by s minus 1. Again log 1 is 0. So 0 minus logarithm of s by s minus 1. Final answer is minus logarithm of s divided by s minus 1. Now we will move on to next question. Find Laplace transform of 1 minus cos t whole divided by t. This is again in the same pattern. The question is divided by the variable t. So we had to use the concept of division by t problem. So first we find the Laplace transform of numerator expression. Here numerator expression is 1 minus cos t. And we have Laplace transform of 1 minus cos t equal to Laplace transform of 1 minus Laplace transform of cos t by applying the linearity problem. It becomes 1 by s minus s by s square plus 1 square. L of cos a t is s by s square plus a square. Here a equal to 1. So L of cos t becomes s by s square plus 1. So we denote this expression as capital F of s. And apply division by t property. So we have Laplace transform of 1 minus cos t whole divided by t equal to integral s to infinity f of s ds. Here f of s is 1 by s minus s by s square plus 1 square. So this becomes integral s to infinity 1 by s minus s by s square plus 1 square into ds. Now we have to integrate this expression. First one we can integrate easily. Second one, numerator and denominator both contains the variable s. So first we look in the denominator. Denominator is s square plus 1 and numerator is s. And derivative of denominator is 2s. So here we multiply numerator by 2 and divided by 2. So we obtain integral s to infinity 1 by s minus 1 by 2 into 2s divided by s square plus 1 into ds by multiplying and divided by 2 in the second expression only. Now we can integrate the result. On integrating, we obtain integral of 1 by s, it is log s, minus integral of 1 by 2 into 2s by s square plus 1. Here we can use integral of f dash x divided by f of x dx. Here numerator is the exact derivative of denominator function. In such cases, integral is logarithm of denominator. That is integral f dash x divided by f of x dx equal to logarithm of f of x. Here denominator is s square plus 1. So we obtain log s minus 1 by 2 into logarithm of s square plus 1 between s and the infinity. So we have to substitute the limits. Again, this is of the form log a minus log b. This is very important step. Here we directly not calculating the corresponding limit or not substituting the limits. So first we have to rearrange the expression. So first we take LCM. LCM is 2. Taking LCM, it becomes 1 by 2 into 2 log s minus logarithm of s square plus 1 between s and infinity. So 2 log s is log s square because a log b can be written as log b raised to a. Again, this is of the form log a minus log b. So it becomes 1 by 2 into logarithm of s square by s square plus 1 between s and infinity. By applying log a minus log b equal to log of a by b. Now we take s square outside from the denominator expression. So denominator becomes s square into 1 plus 1 by s square. Now we can cancel s square from numerator and denominator. And in this step, we can substitute the corresponding limit infinity. So by substituting the limit, upper limit, it becomes 1 by 2 into logarithm of 1 by 1 plus 1 by infinity minus the lower limit is s. So we get the same expression only. Again, 1 by infinity equal to 0. It reduces to 1 by 2 into logarithm of 1 by 1 plus 0 minus logarithm of 1 by 1 plus s square. 1 by 1 plus 1 by s square. And the second term, we have to take the LCM. LCM is s square. So denominator becomes s square plus 1 whole divided by s square. S square numerator becomes in the numerator. So reduces to 1 by 2 into logarithm of 1 minus logarithm of s square by s square plus 1. Again, log 1 equal to 0. So we obtain the final answer as 1 by 2 into logarithm of s square by s square plus 1. One more question. Find the Laplace transform of cos AT minus cos BT whole divided by t. This question is also divided by the variable t. So we had to use the concept of division by t problem. So first we find transform of numerator expression. Here numerator is cos AT minus cos BT. And we have Laplace transform of cos AT minus cos BT is L of cos AT minus L of cos BT. Now L of cos AT is s by s square plus a square. L of cos BT is s by s square plus b square. We denote it as capital F of s. We apply division by t problem. So we obtain Laplace transform of cos AT minus cos BT by t equal to integral s to infinity f of s dx. And here we substitute the value of f of s. So we obtain integral s to infinity s by s square plus a square minus s by s square plus b square into ds. And in this question also, we have to rearrange the expression again to integrate this term, these two times. Again, numerator can be rearranged in terms of derivative of denominator. For that, we have to multiply numerator by 2s. To compensate, we have to multiply by 1 by 2 also. So numerator becomes exact derivative of denominator in two terms, these two terms. So we can use the result integral f dash x divided by f of x dx. It is logarithm of f of x or logarithm of denominator. For the first term, denominator is s square plus a square. Second term, denominator is s square plus b square. On integrating, we obtain 1 by 2 into logarithm of by using this result. Now this is of the form log a minus log b. So first we rearrange the expression. Is log of a by b between the limits s and infinity. Again, to substitute the upper limit infinity, we take positive powers of s from both numerator and denominator. In the numerator, positive power of s is s square. Denominator, again positive power of s is s square. So we take s square outside from both numerator and denominator. Now we can cancel s square. So it becomes 1 by 2 logarithm of 1 plus a square by s square divided by 1 plus b square by s square between the limits s and infinity. Now we can substitute the corresponding limits. Here upper limit is infinity. So here we substitute infinity. Lower limit is s. So we get the same expression. Now constant by infinity is 0. K by infinity equal to 0 where k is a constant. So a square by infinity equals 0 and b square by infinity is also equal to 0. So it reduces to 1 by 2 into logarithm of 1 plus 0 divided by 1 plus 0 minus logarithm of 1 plus a square by s square divided by 1 plus b square by s square. First term reduces to log 1 and log 1 is 0. And the second term we take LCM, LCM is s square, and in these two terms we can cancel s square. So the final answer is minus 1 by 2 into logarithm of s square plus a square divided by s square plus b square. One more question. Find the Laplace transform of e raised to minus t into sine t all divided by t. In this case also, the expression is divided by the variable. So we had to use the concept of division by t property. So first we find the Laplace transform of numerator. But for this question, numerator is a product of two terms, in which one of the term is exponential function. So if an expression is multiplied by exponential term, we had to apply shifting property. So we find the transform of remaining expression. So remaining expression is sine t. So in this problem, we have to apply two property, division by t property as well as first shifting property. So first we find Laplace transform of sine t. L of sine t is of the form L of sine at. Here a equal to 1. L of sine at is a by s square plus a square. A equal to 1. So we get Laplace transform of sine t equal to 1 by s square plus 1 square. We denote it as capital F of s. And here we apply division by t property. And the shifting property is applied in the last only. By division by t property, we have L of sine t by t equal to integral s to infinity f of s ds. Here f of s is 1 by s square plus 1. So by substituting the value of f of s, we obtain integral s to infinity 1 by s square plus 1 into ds. Now we have to integrate this expression. This is of the form integral 1 by x square plus a square. Integral 1 by x square plus a square is 1 by a tan inverse of x by a. and here a equal to 1. So this becomes 1 by 1 into tan inverse of s by 1 between the limits s and here we can directly substitute the limits. In last two problems we didn't substitute limits directly because the expressions are in terms of logarithms. In such cases, we have to rearrange the expression. And here we can directly substitute the limit. Here upper limit is infinity. So by substituting upper limit infinity, we get tan inverse of infinity minus lower limit is s. So we get the same expression. Tan inverse of s only. S by 1 equal to s. Now tan inverse of infinity is pi by 2. So pi by 2 minus tan inverse of s. Now there is a standard result. Pi by 2 minus tan inverse s can be written as cot inverse of s. So this is the Laplace transform of sin t by t is cot inverse s. We denote the expression as g of s. But our question was to find the Laplace transform of e raised to minus t into sin t by t. So now we apply shifting property. Here a equal to 1. So Laplace transform of e raised to minus t into sin t by t equal to g of s plus 1. Here g of s is cot inverse of s. So we get the answer as cot inverse of s plus 1. So here we apply both division by t property and first shifting property. Now I move on to next topic, transform of derivatives. These are very important results because we study Laplace transform. Our application of Laplace transform is to solve differential equations. And for solving differential equations, we use the corresponding equations of transform of derivatives. So these are the very important results. If Laplace transform of f of t equal to capital F of s, then first one is Laplace transform of f dash t. F dash is d by dt of f of t is equal to s into f of s minus f of 0. Here f of s, capital F of s, it is the Laplace transform of the function f of t, and f of 0, small f of 0, is obtained by replacing t equal to 0 in the function f of t. Second result, Laplace transform of f double dash t equal to s square into capital F of s minus s into f of 0 minus f dash 0. One more, Laplace transform of f triple dash t equal to s cube f of s minus s square f of 0 minus s f dash 0 minus f double dash 0. And in general, Laplace transform of f n dash t means nth derivative of the function f of t is equal to s raised to n into capital F of s minus s raised to n minus 1 into f of 0 minus s raised to n minus 2 into f dash 0 minus etc. minus f raised to n minus 1 dash of 0. So these results are the main building blocks for solving differential equations. And we consider these results in the last topic. Now next topic, transform of integrals. The result is if L of f of t equal to capital F of s, then L of integral 0 to t f of t dt equal to f of s divided by s. Here we have to find Laplace transform of integration of the function f of t with respect to t between the limits 0 and t. In such cases, first we find Laplace transform of the integrand. And here integrand is f of t. We doesn't integrate the expression. We consider the integrand. Here it is f of t. And we find the Laplace transform of f of t. This is denoted by f of s. Then Laplace transform of integral 0 to t f of t dt. It is obtained by dividing f of s by the variable s. So we does not integrate the expression. We just find Laplace transform of integrand only. And the final result is obtained by dividing f of s by s. Now move on to problem session. First problem. Find Laplace transform of integral 0 to t cos t dt. So here we had to apply transform of integrals. We had not that we doesn't integrate the expression. We just find the Laplace transform of integrand. Here integrand is cos t. So first find Laplace transform of cos t. L of cos t is s by s square plus 1 square because a is 1. L of cos a t is s by s square plus a square. Here a equal to 1. So it reduces to s by s square plus 1. We denote it as f of s. Then we can use transform of integrals. By using transform of integrals, we have Laplace transform of integral 0 to t f of t dt equal to capital F of s by s. Here f of s is s by s square plus 1. By substituting, get the answer as 1 by s square plus 1. We can verify the result also. By integrating cos t, we obtain integral of cos t is sin t between 0 and t. By substituting limit, it becomes sin t only. And we have Laplace transform of sin t is 1 by s square plus 1 square. So this is the same result. But in this question we can directly integrate the expression. Some question we cannot directly integrate the expression. Anyway, we doesn't integrate the expression I just mentioned. We can integrate and find the corresponding Laplace transform. Next question. Find Laplace transform of integral 0 to t e raised to minus t into cos t. So here we have to use the concept of transform of integral. In such cases, we had to find transform of integrand is e raised to minus t into cos t in this problem. And it is product of two terms, in which one term is exponential term. So we have to apply first shifting property. So first we find transform of remaining expression. Remaining expression is cos t. L of cos t is s by s square plus 1 square, or it is s by s square plus 1. We denote it as f of s. Now apply first shifting property. We get Laplace transform of e raised to minus t into cos t equal to f of s plus 1, because this expression is multiplied by e raised to minus t. So it becomes s plus 1 all divided by s plus 1 whole square plus 1. Denominator we can rearrange. So it becomes s plus 1 divided by s square plus 2s plus 2. We denote it as g of s. So this is the transform of e raised to minus t into cos t. But our question was to find Laplace transform of integral 0 to t e raised to minus t into cos t dt. For that, we had to use the concept of transform of integrals. It is obtained by dividing Laplace transform of integrand by the variable s. So here Laplace transform of integrand, it is g of s. So the final answer is g of s by s. Substitute the value of g of s here. The final answer is s plus 1 all divided by s into s square plus 2s plus 2. One more question. Evaluate Laplace transform of integral 0 to t e raised to t into sin t by t to dt. So again, the question involves integration. So we had to use the concept of transform of integrals. So first to find the Laplace transform of integrand. In this case, integrand is e raised to t into sin t by t. So here the expression is divided by t as well as it is multiplied by exponential term. So we have to apply division by t property as well as shifting property. So first we find Laplace transform of the remaining term is sin t. We have Laplace transform of sin t is 1 by s square plus 1 square, or it is 1 by s square plus 1. We denote it as f of s. Then apply Laplace transform of division by t property. By division by t property, we get Laplace transform of sin t by t is integral s to infinity f of s ds. Here f of s is 1 by s square plus 1. And it is of the form integral 1 by x square plus a square dx. Is 1 by a tan inverse x by a. So integrating this expression using the result, we obtain 1 by 1 tan inverse s by 1 between s and infinity. We can apply the limits directly. So it becomes tan inverse infinity minus tan inverse of s. Tan inverse of infinity is pi by 2. Pi by 2 minus tan inverse s. Pi by 2 minus tan inverse s can be written as cot inverse of s. It can be denoted by capital G of s. This is the transform of sin t by t. Then we have to apply shifting property. So Laplace transform of e raised to t into sin t by t is equal to g of s minus 1 by applying shifting property. Here g of s is cot inverse of s. So g of s minus 1 is cot inverse of s minus 1. We denote it as h of s. Then we had to use the concept of transform of integral also. By using transform of integral, we have Laplace transform of integral 0 to t f of t dt equal to f of s by s. Here f of s is the transform of integrand, and here integrand was e raised to t into sin t by t. Its transform, it is denoted by h of s. So the final answer is h of s divided by s. The answer is cot inverse of s minus 1 all divided by s. So for this question, we had to apply three properties. First apply division by t property, then apply shifting property, and finally use transform of integrals. So these results are interconnected. We have to remember all these results till the end of the module. And another application of Laplace transform is we can integrate some improper integrals using the concept of Laplace transform. By definition, we have L of f of t, Laplace transform of f of t equal to integral 0 to infinity f of t into e raised to minus st dt. This is the actual definition of Laplace transform. but we mainly use the general results. Hello? Hello? I cannot hear you. I think there is a problem with my headset. Now okay. Now I can hear. Sorry. I think there is.
Sir, this is Veena. Can you hear me?
Yes. I can hear you.
So I think there is some issue with 𝐶𝐚𝐩𝐿 net connectivity issue ഉണ്ടെന്ന് തോന്നുന്നു. നമുക്ക് കേൾക്കാൻ പറ്റുന്നില്ല.
Okay.
ഞാൻ ഇവിടുന്ന് ടേക്ക് ഓവർ ചെയ്യാണ്. കുറച്ച് ക്വസ്റ്റ്യൻസ് ഉണ്ട് ചോദിക്കട്ടെ സർ.
ചോദിച്ചോളൂ.
ഓക്കെ, കാവ്യ മദൻ എന്ന് പറഞ്ഞ സ്റ്റുഡന്റ് ചോദിച്ചിരിക്കുന്നത് the fourth problem, can we get the answer by first applying shift property?
In the fourth problem,
can we get the answer by first applying shift property?
Fourth problem. Just a minute. Fourth problem in which session?
She has just mentioned fourth problem.
Maybe this one.
Yeah, I think so. We'll explain this. നമുക്ക് detail ആയിട്ട് ചോദിക്കുകയാണെങ്കിൽ നമുക്ക് ആ ക്വസ്റ്റ്യനിലേക്ക് തിരിച്ചുവരാം.
Okay. Here the expression is multiplied by exponential function and it is divided by the variable t. So it is easy to apply division by t property first and finally apply the first shifting property. We can do this problem in two different ways. First we can apply the shifting property, then apply division by t property. But easy way is first apply division by t and last apply the shifting property. So shifting property is applied towards the end of the question. So if we adopt that, if we adopt that pattern, then we can do the question in an easy way. Otherwise, more rearrangements are required to complete the problem.
Okay.
Order is if multiplication by t or division by t, it also contains exponential term, then we have to apply shifting property, and shifting property is applied towards the end of the problem. I think by this explanation it is clear.
Okay, so same question ആണെന്ന് തോന്നുന്നു കാവ്യ ഉദ്ദേശിച്ചത്. Next we have a question from Arsha.
Okay.
That is, in Laplace transform of integral, can we directly do integration and find Laplace?
Okay, we can integrate some functions, but in many of the cases, the functions may not be directly integrable. So, in such cases, we doesn't integrate the expression. We find the Laplace transform of integral and then divide that expression by the variable s to find the Laplace transform of integral 0 to t some function of t into dt. Because integration, for example, consider this question. Integration of this expression is not so easy. Here the question is to find Laplace transform of integral 0 to t e raised to t into sin t by t into dt. Integration of this expression is not so easy. So first we find Laplace transform of the integrand. Laplace transform of integrand. Integrand is e raised to t into sin t by t. Then apply transform of integral. It doesn't integrate the given expression. Next question.
Sir, നമുക്ക് ടൈം ലിമിറ്റ് എത്താറായി. സോ ഒരു ക്വസ്റ്റ്യൻ കൂടി ചോദിച്ചിട്ട് നമുക്ക് വൈൻഡ് അപ്പ് ചെയ്യാം. ഒരു ക്വസ്റ്റ്യൻ ഉള്ളത്, വാട്ട് ഇസ് ലൈക് ലാപ്ലാസ് ട്രാൻസ്ഫോർമേഷന്റെ നമ്മൾ എഞ്ചിനീയറിംഗിൽ എന്താണ് അതിന്റെ ഒരു ആപ്ലിക്കേഷൻ എന്താണെന്നാണ് ചോദിച്ചിരിക്കുന്നത്.
Laplace transform have many applications in science and engineering, because when we model a problem mathematically, there comes differential equations. If we model a continuous time system, there comes differential equations. So solution of differential equations is not an easy job. Laplace transform, it is a powerful tool for solving any kind of differential equations. But for this session, we mainly consider solution of ordinary differential equations. So the main application of Laplace transform is to solve differential equations. That is the relevance of this topic in engineering. Any questions?
So we have a few more questions. അത് ഞങ്ങൾ ഓഫ്ലൈൻ ആയിട്ട് സാറിന് മെയിൽ ചെയ്യാം.
Okay.
നമുക്ക് നമ്മള് സെഷൻ വൈൻഡ് അപ്പ് ചെയ്യാണ്. I just asked if Santosh is here so he can wind up, otherwise I'll wind up. Santosh, can you hear me? Santosh, engineering connectivity ready ആയിട്ടില്ലെന്ന് തോന്നുന്നു. So it was wonderful. എന്തെങ്കിലും സാറിന് ഈ സെഷൻ വൈൻഡ് അപ്പ് ചെയ്യാനായിട്ട് എന്തെങ്കിലും രണ്ട് വാക്ക് പറയാനുണ്ടോ?
Okay. Laplace transform, it is a very lengthy module. I think I need total 5 sessions to complete this module. So around 40% of the topic can complete in these 2 sessions. The main problem with this Laplace transform is students have to memorize the first result to the end of the module. That is the main challenge students were facing. They have to memorize many results. Laplace transform 1, it is 1 by s, and the students have to memorize towards the end of the module, because we study these topics to solve differential equations. So to solve differential equation, we require Laplace transform as well as inverse Laplace transform. So thank you for all students for watching this session. Thank you for your patient listening.
Thank you, sir. So dear students, we have Mr. 𝐿𝐶𝐚𝐲𝐿, Assistant Professor, Department of Science and Humanities, of research with us. Thank you so much for the very wonderful session, and we had a very great participation today. We will be waiting for more sessions from you. Thank you.